Well, hello everybody. Welcome back to another week of 141 Lab. Seems like every Monday we talk to you, they've extended quarantines for another X period of time or canceled even more university events. So sadly, uh, while there's more bad news out there in the world, we just have to keep trucking along here. Looks like we have a few more people signing in here, so I'll stall a minute or two while we uh, wait for everybody's technology to get going here. Just in case you do get disconnected, as I've said before, I'm recording this, so everything that I'm going to show you here and everything that you're seeing and hearing on the screen, I'll turn that into a YouTube, and shortly after we are finished here, I can upload that, email that out, and also put that in Blackboard for you. Just a couple comments to echo off of what I emailed to you already. Thank you for your hard work. This is not easy. This is challenging. It is challenging to run a lab course that is both educational and useful for you. You know, I don't want this to be so frustrating and maddening that you're getting angry, but at the same time, I want you, to have a robust college experience. I mean, that's what you're paying for. You're paying for learning those skills and gaining that knowledge that are going to turn you into the great men and women you will be. So you guys have really been doing well overall. I've been getting lots of communication from you guys, lots of questions, so keep them coming. I'll just reiterate what I said in the email, that sending me a version of your Excel file or of a version of that lab report ahead of time, I can very easily look that over and give you guys pointers, tips and tricks, because this is hard to do. It's hard to do it right. It's hard to do it right the first time. There is always the possibility for formula errors and issues, particularly in this week. So we really are stepping it up a notch this week in terms of some of the physics and in terms of some of the error propagation. So we'll discuss that first here as we go on. Feel free to throw any comments or thoughts or suggestions, anything you need me to discuss or talk about over in that comments section on the right. I'll kind of keep monitoring that in the background as I talk here. So I'll give you a minute, if you haven't already done so, to open up to Lab 6 in your lab manual. Lab 6 is on rotational motion. So we'll kind of follow along there with what I'm saying and what I'm showing you. So we're still using the conservation of momentum concept. I would, I guess, ask if you wouldn't mind just throwing a few blurbs into the comment section. Have you studied rotational motion in the physics class to this point? It will be a little bit of an issue if you haven't, if you have not yet studied rotational motion. I have been communicating with the others in my department, so it's my understanding at least you've been introduced to it. However, I'm not sure when the due dates or the lectures are actually held, because normally they are already, those topics are covered. So it's good to see that some of you are saying that you have at least covered it. If you have a basic understanding of it, that is fine. We study the lab aspect of it here, so that is good to see. So the video then explains the concept of conservation of momentum in the rotational sense, and the idea that there is a moment of inertia. So really, this lab, the first part of it, has us deal with understanding and programming into Excel the calculation of a moment of inertia. The data that I gathered in the video that hopefully you watched by this point is essentially the angular velocity. And by putting those two items together, plus some basic measurements about the disks that you saw rotating in the video, you can calculate the momentum of both of those disks before and after. So again, the idea, as it was in previous weeks, is to test the conservation of momentum in the sense that we are going to compare the momentum of those two disks before to the momentum of those two disks after some collision that involves a rotational sense, a rotational aspect to it. And we would expect that value to be 0. Let me just walk you through a few of the specifics of the lab. It'll take me just a second to switch over to my screen. that shows the spreadsheet. There we go. I'm getting better at this. So the software that I used when I was making the video exports data here. These are simply every 50th of a second. They are angle measurements, as you can see my cursor clicking on, and also angular velocity measurements that are taken every 50th of a second, or every 0.05 seconds. As I scroll down here, I want you to notice that these values were taken before the collision happened. These values were occurring as the disk was slamming on down to as the disk I was holding was sort of coming in contact to and coming into impact with the disk that was rotating on the stage. These values are after the collision has occurred, in the sense that now both disks are rotating at the same velocity. There's no slipping going on, essentially. You can see that there was a drastic reduction in angular velocity, as you would expect. And so the velocities have more or less stabilized here. So this is the raw data that you're given, and we did 5 different trials. And so those will be needed, obviously, as we continue on to the analysis part. Your job, essentially, is to complete this template. So on the next tab down below, I have disk calculations. I've provided the information that you need. I have provided the diameter of the disk that I measured up here. I measured the diameter 6 times and provided that information for you. So hopefully you can envision a way or visualize, calculate a way to get a good value for the radius and also the error on the radius. The word standard deviation should come to mind there for the error on the radius. Don't forget to divide these in half to get the radius. That's another common mistake. And then just simply proceed through the analysis here. Once you have the calculations for the radius and for the moment of inertia of both disks, then it's your job to think of a way, as the lab report says, to estimate omega, or the velocity for each. There are many possible ways to do this. The words average and standard deviation, however, should come to mind, right? You have plenty of points before that you could use and take an average and a standard deviation for, and plenty of points after that you could use to take an average and a standard deviation for. Taking a close look at the data, there is a slight slowing down in the data here just because of friction and air resistance. So some people might be tempted to just take the average of all of these, and if you feel like that's the best method, go for it. Some people might be tempted to just go with a handful right before and right after, since that should theoretically be closer to the initial value, and the average here should be closer to the final value. Calculating error is a huge part of this lab, and so calculating the error on the angular velocity and the error on the moment of inertia is critical here. So I'm not going to read you the lab manual. However, the lab manual does give you the formulas, particularly the difficult one, which is the error on the moment of inertia. And so please be sure to read about error propagation in the lab manual, in Lab 6. And we do give you, if you want to flip over to page 6.2, or the second page of the lab, in the lab manual, we do provide you 2 equations there. We provide you the equation for the moment of inertia of a solid disk that's rotating about its center. And then we also provide you the formula for the error on that. And so these come from Appendix C. So we didn't make these up. They they are derived from the rules that you would follow in Appendix C. And then it's your job to program that into the proper place here on this spreadsheet. Sigma m over m and sigma r over r are what's known as the percent error or fractional error. So the reason why we have you calculate these values right here that I'm highlighting and right here that I'm highlighting are because it makes programming those error propagation formulas much easier. It makes the programming simpler. That being said, there is commonly Excel formula mistakes in this, so don't be afraid to send me a rough draft and ask me to take a look at some of your values here before you're done, so that you can know if that's correct. I'll switch over really quickly here to the lab report, just to highlight a couple things. We are only going to be doing, I should add that this is a 2-week lab, as it says in Blackboard. And so the idea would be that you would complete this first tab during this upcoming week and complete these unknown objects. They're sort of the second portion during the second week. So this won't be due for, until a week from Friday. So you've got a little bit of time to tackle this, and that's okay. You might need it because there may need to be some more back and forth going on between you and me to get it right, and that's fully expected. That's okay, and it should happen. Definitely highlighting, explaining how you found the angular speed and estimating its uncertainty, and showing those calculations in Excel. So we do need to be sure that we are explaining why we did it the way we did it, explaining what we did, and then showing those calculations in the spreadsheet. I don't want anybody typing things in their calculator. Show all of those calculations that you used in Excel. Finally, I walk you through, in some of these, number 5 and 6, I walk you through the steps for showing conservation of momentum in the YouTube video. So it's critical to watch those that video that I showed. I showed you some steps on the board in the classroom for that. And then as we're having a discussion on error, on random and systematic error, this is a great chance to reach out to me. Send me a quick message in Google Hangouts. Hey, I was thinking this for sources of random error, or I was thinking about this as a source of systematic error. Does that make sense to you? We can have that conversation, and we should. Past this point, I'm gonna talk about everything past number 8. Looks like I missed number 9 there in the report. Sorry about that, but we do switch. I just want to highlight the fact that everything after section D in the lab report is different. So we are not following any of the steps in the lab manual past D. I give you some additional instructions in Blackboard that will make, so these questions won't make sense if you're following the lab manual past D. They will make sense if you read the changes that I made in Blackboard that have to do with an unknown object. So we'll discuss this next week at this time. We won't get into this week. I'm going to stop here and switch back over to the camera. You can see me and see if you guys have any questions, comments, or concerns. I do just want to highlight that I'm really proud of everybody here. The work that I'm seeing is fantastic, given the situations we're in. And this is just not easy for any of us. It's been a struggle for me to try to keep things relevant, and also to judge the amount of material to give you and the amount of help to give you. So if I'm doing anything that seems way too much or way too little, even, feel free just to give me an honest opinion. And I'm trying to be very, very flexible in due dates. I'm trying to be flexible in terms of, okay, you turned something in that was a huge mistake. Let's fix this and get it right. I don't want anybody's grade to be destroyed by the fact that we can't see each other in person. So please know that I am sympathetic to any of the stresses that you guys are going through. And my prayers and wishes are with all of you for keeping healthy and staying healthy, and same to your families as well. So I can stay on here for another minute or two, but unless there's any other questions or comments, feel free to log off. Just get in touch with me in any of the ways that you feel comfortable with, including that discussion board in Blackboard.